Okay, so the test is going to be in two parts. So the chapter 2 test is going to look like what you see here. And it follows this very, very closely. The first thing we're going to do is graphing. To graph a line in slope-intercept form. So if we look at this first one here, remember, if you have y equals mx plus b, that is your slope, and that is your y-intercept. So we can quickly answer the fact that the slope of this line is negative 1/3, and the y-intercept is the point 0, 3. So remember, I prefer the point to be, or the y-intercept to be written as a point. You know, you may not, but okay. So let's go ahead and graph it. We're going to start at 3 on the y-axis. You can plug any points you want, I don't care. But you're going to go down 1 and over 3. And then, you know, I didn't give you tons of room, so just stretch it out as much as your graph paper allows. You know, if you want to hit that point down there, that's fine. But so that is just graphing the line in slope-intercept form. Nothing too fancy, right? Okay. Now, if we want to graph it in standard form, well, that's barely standard form. I don't know why I wrote the y first, but anyway, I suggest doing this little trick. So I put that on there to remind you that that's a good tool to use, because it's also going to give us the x and the y-intercept. Now remember, the first one here is our y-intercept, and that's where x equals 0. So if this is 0, you really end up with 2y equals 14. And 2y equals 14 is very easy to solve. You just divide by 2, you get y is 7. So the y-intercept is 7. So let's put that as 0, 7. And we can go right to the graph paper, and you can count up 7. 1, 2, 3, 4, 5, 6, 7. Okay, so let's assume I gave you enough room. Now, our x-intercept, you're going to let y equals 0. So if this term equals 0, you get negative 7x equals 14. When you divide by negative 7, you get x is negative 2. So that is the point negative 2, 0. So you can go on the on the x-axis, and you can put the point negative 2, and then just connect them. Okay? So the first two questions are just graphing lines. Graph this one is going to be in slope-intercept form, and the other one is going to be in kind of almost standard form. Everybody okay with our first two types of questions? Okay. The next thing I'm going to ask you about is distance and midpoint. So let me give you the distance formula. The distance formula is the square root of the difference of the x's, is usually it's written x2 minus x1 squared, plus the difference of the y squared. Now this comes completely from the Pythagorean theorem. So if you were to draw a triangle perfectly lined up, this will end up being the x squared, and this will end up being the y squared. So you can use Pythagorean theorem to find that distance. In this particular case, I would suggest taking just a moment and writing down the coordinates of your A and B points. So this first point here is 2, 1. No, it is not. It is not. You're going to go to the left 1 and up 2. So it's the point 1, 2. And then B is the point negative 1, negative 1. Now, it doesn't matter which one you call your x2 or your x1. As long as you're consistent about it, then it should be fine. So I'm going to label this x1, y1, and this x2, y2. Again, doesn't matter. Just be consistent. You'll be fine. So if we subtract the x's, that's going to be 1 minus a negative 1. which would become a 1 plus 1. And then plus the difference of our y, so it's going to be 2 minus a negative 1, which are going to be plus 1. So just note, because we are subtracting, this sign always switches. Do your quantity first before you take the square root. So 1 plus 1 is 2, 2 squared is 4. 2 plus 1 is 3, 3 squared is 9. We get the square root of 13. Now, if your square root can reduce it as much as you can and then just stop. That's your answer. I don't want any kind of decimal value. So our answer is square root of 13. Now, midpoint, let me give you that formula. The midpoint formula is the average of the x's. So to average x's, you add them up, and since I had two things, I divide by 2. And the average of the y's, so add it up and divide by 2. So if I add up the x's, I get 1 plus negative 1, which is 0 over 2. If I add up the y's, I get 2 plus negative 1, which is 1 over 2. And many times you're going to get a fraction with a 2 denominator and leave it unless it can reduce. 0 divided by 2 is 0. 1 divided by 2, I can't reduce, so I'm going to get 1/2. Now, if I graph this little line segment correctly, if you go up to 0, 1/2, it should look and appear as if it is the halfway point. Okay? Is there any questions about our distance or our midpoint formulas? So make sure you know those formulas. That will be on part 1 of the test. So now I'm going to scooch to the right of number 3. 4, 5, and 6 are solving equations. So if we look at number 4, to solve that equation, let's just get the x's to one side, numbers to the other side. Reduce your answer as much as you can. Okay, 3x we are going to subtract from both sides, giving us 2x. When we add 2 to both sides, we do get 9. And then if we divide by 2, just leave it 9 over 2. If that fraction can reduce it. Don't waste your time putting it as a decimal. I like 9 over 2. It's great. It's fine. It's wonderful. So fractional answers are okay. Just leave it. Do we have any questions about number 4? Okay, let's take a look at number 5. For number 5, the first thing I'm going to suggest that we do is let's distribute that -3 into both quantities. Now, I made this equation pretty quick, so the odds of it being a nice number are pretty slim. But 10 minus 6 is 4, so I would simplify down both sides. Okay. So if I subtract 2x from both sides, and if I subtract 4 from both sides, I get negative 5x equals negative 9. Is that what you guys got too? We good? Does that look better? And then we divide by negative 5. We get negative 9 over negative 5. The two negatives are going to cancel. Just leave it as 9 over 5. Yes. Oh, yeah. And remember, I'm going to show you the way that my insane brain thinks of it. So if you do it a slightly different way, if you move them to the other side, whatever, you'll end up getting a very similar, you'll get the same answer, but in a slightly different fashion. Okay. Now, number 6, I don't know why I put the 1 in the middle. I don't know, but anyway. That is a factorable quantity. I will post this for you so you can get it finished, okay? Okay. So If you notice it is a quadratic, a second power that is factorable, let's go ahead and factor it. So what are the factors of 6 that have a difference of 1? 3 and 2. So we're going to have a plus 3 and a minus 2. That's going to give us the negative 6 in the back, but the positive 1 in the middle. So then remember, you're going to split each one up and solve them. So x plus 3 equals 0 gives you a negative 3 answer. X minus 2 equals 0 gives you a positive 2 answer. So for your quadratics, for the most part, you are going to get 2 answers. Now, unfortunately, 7 is not factorable. There's no way to have the factors of 6 add up to negative 2, because you can use negative 6 and negative 1, which is negative 7, or negative 3 and negative 2, which is negative 5. There's no way to add up to negative 2. It just doesn't work. So when that's the case, please use the quadratic formula. So let me write it over here to the side. Make sure you look that over before you take part 1 of the test. So it is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I did put 2 quadratics on the test. One is factorable, one is not. So I suggest using the quadratic formula. Yes.
Will the test be in like this order?
Yes. Okay. So our A is 1, our B is negative 2, our C is 6. So we're going to plug those values in and then simplify it as much as you can. So we're going to get 2 plus or minus the square root. Now, I would do negative 2 squared in my head. Negative 2 squared is positive 4. And then negative 4 times 1 times 6 comes next, which is negative 24. And then 2a's, a is worth 1, so 2 of them is worth 2. So you get 2 plus or minus the square root of negative 20 over 2. Now, although that is the correct answer, it is not in the correct form. Now let's discuss the square root of negative 20. Let's discuss what we do there. You want to think about that is as a negative 1 times a 4 times a 5. Because a negative 1 becomes it becomes an I. And so the 4 is the only factor in a 20 that is a perfect square. So I can evaluate the square root of the negative as an I. I can evaluate the square root of 4 as a 2. I can't evaluate the square root of 5, so I'm going to leave it. So it's going to be 2i square root of 5. So that's what that piece is right there, okay? So now I'm going to write it as 2 plus or minus 2i square root of 5 over 2. Now the over 2 implies that that 2 is divided into both of those pieces, both of those terms. So if it doesn't divide into both of them, the outer pieces, then leave it alone, just that's your answer. But if all 3 of these have to be divisible by the same thing to proceed, they're all divisible by 2. So we get 1 plus or minus 1i. Now, if you are a person that put the 1, I'm good with that. I don't care. The 2 now on the bottom has been reduced down to a 1, so you don't have to write anything underneath it, okay? So you will have one that's factorable, one that's not. The one that is not, please reduce it down as much as possible. If it has a negative under the square root, just write that I notation for me. Any questions about number 7? Okay, now let's scooch over here to where it says number 8. So number 8 is about some rules of complex numbers. So the first quantity here, there is a minus between them. If there's a plus or minus, you're just combining like terms. But if there's a minus, make sure you rewrite it as being distributed by negative 1. So I'm going to write that as 7 plus I minus 5 plus 2i. And then I'm going to combine like terms. So the 7 minus 5 becomes a 2. It's just a plain old number. Plain old numbers, put them together. And then i's, at this point, we just get to treat like they're an x or a y or any other variable. 1i plus 2i's is a total of 3i. And then you can't go further. That is your final answer. Are we good there? Okay, so let me tell you what 8b says, because that's so sloppy. I'm so sorry. My pen was, I know. 3 plus I times the quantity of 4 minus 2i is what it should say. 3 plus I times the quantity of 4 minus 2i. Now, the fact we're going to use that you need in your brain is that I squared equals -1. So please remember, you have to know that I squared equals -1. Okay. Now, this becomes, since if the parentheses are touching, it is a multiplication problem. So let's take and distribute the 3 to both pieces. Then we're going to distribute the I to both pieces. Let me show you what you get. You get 12 minus 6i plus 4i minus 2i squared. Now, we said earlier that I squared was equal to -1. So if you see this little I squared right here, that I squared right there needs to be replaced by -1. So it just really multiplies by whatever it's touching and multiplies it by a -1. So -2 times -1 is a 2. So this is really going to be 12 minus 6i plus 4i plus 2. Okay? And then once everything is simplified, the I squareds have become a -1. Combine your like terms. So 12 plus 2 is 14. -6i plus 4i is positive 2i. Now, it's customary to write the I second, but if you wrote on your paper 2i plus 14, it is correct. But those standards, it does usually do that. Oh, you should get -2. Thank you. So -6i plus 4i is -2i. Okay. Now, for C, if there is an I term, just an I term sitting in front of a complex number, we are just going to distribute that to both pieces. Any I squareds are going to become -1. So we're going to get 21 I minus 6i squared. Now remember, I squared is -1. So if it's touching a -6, -6 times -1 is a +6. And then that's as far as you have to go. The I terms and the number terms cannot be combined. If you wanted to write it in like standard form for a complex number, usually the number part will come first and the I part will come second. There's no penalty there. If you write 21i plus 6 or 6 plus 21i, they're the same exact darn thing. Okay. So that is a good indication of the front of part 1. Okay. Do we have any questions on that first section 1 through 8? Okay. Now let's look at the last part of part 1. So to simplify this, we have more complex numbers. So on the last page, you saw multiplication with complex numbers, addition, subtraction with complex numbers. So now there are some division. There's going to be 2 of them. In 9a, we're just dividing off a 2i. To do that, surround the top in parentheses. And what you want to do is you want to multiply top and bottom by the opposite of 2i, so -2i. Now, the reason we do that is because we want to not have negatives in our denominator. And if we don't include the opposite, you'll have to take care of that in a separate step. This just kind of does it all in one step. And so we're going to distribute this just like we did on problem 8. we're going to get negative 6i plus 8i squared. And then a negative 2i times a positive 2i is a negative 4i squared. Now, before you proceed, let's make all of the I squareds negative ones. So we get negative 6i minus 8 over positive 4. Now, let's get in the habit of splitting that apart into the complex piece and the real piece. The real piece is the negative 8 over 4. Negative 8 over 4 is just the number negative 2. So it simplifies perfectly. So let's write minus 2 first. Negative 6i over 4, negative 6 over 4, both pieces are divisible by 2, but nothing more than that. So just leave that minus 3 halves and then separate your I. If you put your I up there by the 3, negative 3i over 2, that's fine too. So there's a few different ways to write that. So let me tell you again what I did. I did the 4 went into the negative 8, negative 2 times. 6 over 4 can reduce, but not perfectly. It just reduces to 3 over 2. And I separated because that one was negative. Everyone okay with that division? Okay, let's look at 9b. Remember how I told you the conjugate of 2i, or the thing to use, is negative 2i, and it comes from conjugates. So the conjugate here we would use is always the conjugate of your bottom. So we're going to multiply top and bottom by 5 plus I. Now when we do that, the bottom should turn out nicely. So let's do the bottom first. You have to distribute. So we have to use 5 times both of those, negative I times both of those. And then we're going to do 2 times both of those, and then I times both of those. So you have to distribute on top and bottom. When you distribute the bottom, because they're conjugates, things cancel out. Now, if you know ahead of time how that's going to cancel out, you go for it. But I'm going to write down the whole thing for those of you that don't remember that. We're going to get 25 plus 5i minus 5i. That's what I mean by things are going to cancel out. And then we have a negative I squared. And now we're ready to distribute on top. So we've got 10 plus 2i plus 5i plus I squared. Now on the bottom, let's discuss that first. The two negatives are going to cancel, or the two opposites are going to cancel, positive 5i and negative 5i. This is going to become negative 1 times negative 1, or it's going to become a plus 1. On the top, this I squared is going to become a minus 1. So if we keep that in mind, then you can just combine like terms. So on top, we are going to get 10 minus 1 is 9. 2 i's and 5 i's is a total of 7 i's. And then 25 plus 1 is 26. Now that's okay, but we should get in the habit of splitting apart a complex number. So just write both pieces over 26. 9 over 26 plus 7 over 26 has the I on it. Now 9 over 26 and 7 over 26 are not reducible. 26 is 2 times 13. Neither 2 nor 13 go into 9 or 7. So that is your final answer there.
Why don't we put the I on with the 7? Like, why do we separate?
So you can put the I right next to the 7. So if you wrote 7i over 26, I'm going to give it to you. It's perfect. It's fine. The standard form of a complex number is a plus bi. So they do separate the real part plus whatever's multiplied by the imaginary part, and then your I. That's standard I am okay. And even when if you take calculus in your future, that's going to be good enough. I know Alex wants it like that. So I just want you to get in the habit of knowing how to do that just in case, you're doing something on Alex. Okay. Now let's do, we should be able to finish up these before the end of class. I'm sorry. Okay. Anyway, so the formula you need for slope is y2 minus y1 over x2 minus x1. It doesn't matter which you call x1, y1 or x2, y2 as long as you're consistent about it, just like your distance and midpoint formula. So this is x1, y1. This is x2, y2. I usually just go left to right unless I notice something good, which it is what it is. And so if we subtract the y starting with y2, we get 2 minus 4. If we subtract the x's starting with x2, we get -1 minus a -3. So you might notice that always changes sign. So that's going to become +3. Now I always glance for a moment of the setup. Glance at the setup. Is this a pair? Is -1, 2 a pair? Yes. Is this a pair? Now you have to think of opposites of what you see there. So is -3, +4 a pair? Yes. The x's should always be in the bottom. The y should always be in the top because it's rise over run. So we get -2 over +2 for a slope of -1. Now, if you left it -2 over 2, that's okay. -1 over 1, that's okay too. Okay, now let's graph 11 and 12. The slope of a x equals 5 number, remember, that is vertical. Since it's rise over run, run implies how you're moving left to right. A line like this doesn't change any from left to right, so you get that 0 denominator. So that's why this is undefined. So you can give me the null set or you can say undefined. Okay, it doesn't work. And all you got to do is find the x-intercept of 5. Where does x equal 5? And make your vertical line. Now, if it's a y equals a number, remember that's horizontal. Since that's rise over run, it's 0 over a number. 0 in there, your numerator is perfectly acceptable. So that slope is 0. To graph that, just find the y-intercept of -2 and make your line. So just recognize that x equals a number is a vertical line, y equals a number is a horizontal line. Vertical line slope, just think if you were to walk a line, you would fall off of that line. You can't walk up a wall. You don't have spider skills. So that's undefined. I can't walk on it. That's the best kind. 0 effort to walk on a flat surface compared to sloping up or sloping down. Okay. Last two for part 1 of our test are systems of equations. So let's do these two. And then you have some time to work on if you're not done with 2.6 or 2.7. To solve A, because the way that the equation is set up, the x's and the y's equals the number, I would probably use elimination. And I'm going to just multiply this top one here by 2 so that my focus is here on my y's. I'm hoping that I can eliminate the y's. Now, there's so many ways to solve a system. You do you. If you're going to get the same answer I got, go for it. But let me just show you my method. So if I multiply that top equation by 2, I get 4x minus 2y equals -2. And then x plus 2y equals 7. And the reason I know I'm on the right track is because now these are opposites. So when I go to add them together, my y's are going to disappear. They're going to be eliminated from the problem. So I get 5x equals 5 or x equals 1. Now, once you know what x is, you have to do a substitution into either of the equations to find what y is. Now, one's not really any better than the other. I'm just going to use this bottom one. Where the x is sitting, I'm going to put a 1. And then I can solve. So if you subtract 1 from both sides, you get 2y equals 6. Divide off the 2, y is equal to 3. Please write your answer as an ordered pair. Organize your answer. That is the 0.13. So if you were to graph those two lines, they would cross at the 0.13. Okay. Now B, I'm setting up that it lends itself a little bit more towards substitution. Because this equation here says y equals, why not substitute that value into the second equation where you see y? So let's write the second equation. I'm going to put a parenthesis where the y was, and I'm going to put what the first equation said y was equal to. It said it was 3x minus 2. So now I'm going to distribute. So we get 2x minus 9x plus 6 equals negative 1. Let's just start moving things around. We get negative 7x plus 6 equals negative 1. And once both sides are as simple as possible, start moving things over. So if I subtract 6 from both sides, I get that negative 7x equals negative 7. Divide off, you get 1. Now remember, what's great about substitution is you have an equation that y equals 3x minus 2. So if you put that x value of 1 right there, you get that y is 3 minus 2 or 1. So please write your answer as an ordered pair. It's the 0.11. Okay, so that is part 1. We are going to do part 2. If for some reason you're absent, then it's your responsibility to part 2. I'll post those videos tomorrow. So this is what your tests look like. Part 1 follows very much like what we got done today. Okay.